hardware is still the constraint. Software is running ahead of the hardware. For example, you
Yeah,
can create any small language model, any size. The problem is you can't put it inside a size constraint or memory constraint device which runs at an endpoint. And
right.
that is what we're trying to do. We're trying to break that barrier and just keep evolving our product line in such a way to enable that to become more and more a reality.
On this episode of Embedded Insiders, Ken is joined by Alif Semiconductor's founder and president, Reza Kazarounian. The two discuss an ensemble of small footprint, power-efficient solutions capable of running fast AI. In addition to being secure and integrated, the MCUs and fusion processors leverage hardware acceleration for transformer networks. Next, Ken is back with another episode of In Case You Missed It, featuring the latest news from this week. But first, Ken and I are highlighting some of the top things to see and do for those attending Embedded World North America in Anaheim, California next week. Embedded Computing Design will be attending as a media partner, and we're hosting a ton of activities for attendees that you don't want to miss. Hello, everyone, and welcome back to the Embedded Insiders podcast. I'm Assistant Managing Editor Tiara Oliver, and I'm here with our Editor-in-Chief, Ken Briota.
Hi, Tiara. How's it going today?
It's going pretty good. Weather's cooling down.
Yeah, I mean, we've been having lovely autumnal weather here in New England. The current temperature is a delightful 52 degrees, which is excellent. I don't know, how are things in Arizona?
Frustrating, honestly. It needs to be cooler. We're still like reaching high 80s every few days, but
Oof,
yeah, it's exhausting.
no, thank you. No, thank you. You can keep it. I want my sweaters and overcoat at all times.
Understandable.
But I will not be getting those. Do you like this transition? This is real smooth. Next week, as I fly to Anaheim, California for Embedded World North America.
That was a great transition, actually.
Oh, thanks. Yeah, it should be exciting. This is the second year for the Embedded World North America. Obviously, Embedded World in Nuremberg, Germany, has been going on forever, but they just launched this North America edition last year, and they're expecting it to grow here for the second year. So I know we at Embedded Computing Design have grown our presence. We've got a huge booth. We're going to have our dev kit zone is returning from Embedded World Germany. We've got a bunch of the leading edge dev kits that are going to be on display. We're going to be making some videos about that. They're going to be speaking in the booth about the dev kits and the tech there. So I'm excited about that. We've got music.ai is going to be joining us in the booth, doing a kiosk there so that's very cool. Their tech around AI enabled sound and management is really, really cool. So obviously we're doing all the usual giveaways. We're going to be doing t-shirts and some Raspberry Pi boards, a bunch. I think we have 1,000 Raspberry Pi boards that we're going to be giving away. So like doing scavenger hunts, and there's a bunch of different ways to get those. We've got a party that's going to be going on Tuesday night, so folks can come by and grab a beer with us. Our Best in Show awards, I just finished judging those. What, yesterday was it? God, I don't even remember.
Yeah.
So we'll be giving out our Best in Show awards. So if you entered, you should definitely come by and find out if you won. I think we're going to be formally announcing and giving those away on Tuesday morning next week. But you can pick them up anytime during the day or at the party Tuesday night.
Perfect. And we'll have a podcast next week, so I'll be announcing those winners on there too.
Absolutely. It should be very exciting. Lots to go through. And make sure you're checking us out on YouTube. We're going to be doing tons of video from the show. In case you missed it for next week is going to be all all embedded world news. So if for some reason you don't make it to Anaheim for Embedded World North America, don't worry. Your friends at Embedded Computing Design have got you covered. We're going to be getting all the news out that you need to know from the show, hopefully, or at least as much as I can. With me and Caitlin, our videographer, is going to be there with me, helping me out. So lots to do, but it should be a really exciting show. Tiara, you're going to be dearly missed.
I know, but I'll be back here holding down the fort. So
Truly the more important job by a long stretch.
yeah, but as far as all the content we'll be creating, I mean, people staying active on our website, checking out YouTube, and even listening to the podcast, it'll be like you're there.
Yeah. I mean, everybody listening here is obviously already a subscriber to our podcast. But if you haven't subscribed to us on YouTube, make sure you go do that because you don't want to miss out on any of our shows. We've had a great run of DevKit Weeklies recently. I do want to plug something that's not Embedded World related, though, if you'll give me a minute, Tiara. I've been interfacing with a really exciting new, well, not new, but industry association for software-defined vehicles and automotive. It's called SOAFEE, SOAFEE. And I hosted a roundtable with a couple of their executive board members from ARM, and wrote up a piece about it and posted that video last week or the week before, just recently. And there is a new roundtable video up on our website now that you can check out. If you're into the automotive industry, you're into software-defined vehicle, you should be checking out SOAFEE. Watch these videos about their Blueprints program. Really interesting explorations of their technology. The story is really clear. It's really, really cool. I invite everybody to check it out and watch those videos, take a look at the articles, and follow along with SOAFEE. It's really cool stuff.
Awesome. Can't wait to see that. And
Yeah.
for everyone listening, just stay updated on our coverage of Embedded World North America and stay tuned for the upcoming interviews on this podcast. And we'll see you next week. Here's Alif Semiconductor's founder and president, Reza Kazarounian.
Hello, engineers, developers, and professionals in the embedded computing space. Welcome to another segment here in Embedded Insiders. I'm Ken Briota, editor-in-chief of Embedded Computing Design, and I'm very excited to be here with Reza from Alif Semiconductor. Reza, how are you today?
I'm doing great. Thank you for asking. How about yourself?
Wonderful. It's pretty unlikely at this point, but in case we've got any listeners out there who aren't familiar with you or with Alif, why don't you give us a little bit of background before we jump in and start talking about the news?
All right, sure. So Alif Semiconductor is a 6-year-old company. We are a young company. We're no longer a startup. Myself, my background comes from the embedded space. I have come through the ranks of ST Microelectronics, Freescale, and Atmel. I've been in this embedded space for pretty much most of my life. Alif officially, started operation in early 2019. We're about 200 people strong today in multiple locations in California, Singapore, India, and Finland, among other locations where we have team members. Most of our team members come from the embedded space, work pretty much in the tier 1 companies, and I would say probably a lot of products which are introduced in the marketplace and a lot of our customers are using them went through the hands of the people who work at Alif today. Strong background in the embedded space, controllers and processors, and very focused on innovation.
Absolutely. I mean, you guys have most of your history has been involved with the machine learning and AI space, hasn't it? I mean, you've been doing that a long time.
Yeah, I mean, pretty much from the day we started to create the ability to run what we call the AI ML at the endpoint and at the edge was an important part of our strategy. That's how we developed our platform. Honestly, like anything else, when you start a new company, you cannot create a product similar to what is in the market already. You have to create a product that you think the market may want to use for the next 10 years, and you want to be ahead. That's the only way to compete and survive. So we differentiated our platform and architecture of our product around some very key points. One of them was the ability to run AI efficient AI, fast AI, and power efficient. So the ability to run AI, to be very power efficient, and at the same time to be very secure and integrated for small footprint devices was an important part of our strategy. And that's how we have been developing our products.
Yeah, which transitions beautifully into the announcement that you just made this week at time of recording. You've got the new Ensemble E4, E6, and E8 MCUs and Fusion processors. The idea here, I think, is that these are hardware. These include hardware acceleration for transformer networks, which is really exciting, allowing for smaller form factors, if I'm understanding correctly, for imaging and power efficiency, which is of course a huge issue at the edge. Can you give the listeners a little insight into what's a pretty big announcement, I feel like?
Yeah, so I think it would be good to talk a little bit about what we wanted to do just when we started the company, what was the first gen, and then how we ended up on the second gen, correct? So if I go back to 2018 and 19, and if you remember well, the whole topic of edge AI or AI was nothing like what it is today in terms of the market acceleration, the importance, and etc. Honestly, nobody was even talking in 2018. We need to have a standard controllers and processors which can run AI and have an NPU on board, correct?
Right.
We were looking 5 or 10 years down the road, but at that time it was not really demanded. And our product line in general is going to what we call a large multi-billion dollars is a market which is $30 to $40 billion large, but it's extremely fragmented and covers a spectrum of market segments from mobility to automotive, mobility, industrial space, smart home, a smart city, wearable devices, medical devices, etc. So for that fragmented market, at that time, we thought we have to bring the ability to run AI. Because an interesting fact was there are a lot of devices as under the name IoT and others, which are installed in the marketplace, and they usually are connected to different type of sensors. A lot of data which is being collected by the sensors usually gets wasted because the user doesn't know what to do with it.
Yeah.
That is where AI becomes important, because now all of a sudden we thought we can offer the capability that can deal with image sensors, voice, other sensors in the field, whatever, infrastructure type of sensors. But that data could be collected, and you can't constantly transfer data to the cloud because it takes a lot of communication capability, it consumes power, etc. Yeah. So we said, if we create the local processing capability to run an efficient and power efficient AI at the edge and do a fast inferencing, that brings a capability to the marketplace. And honestly, I don't know if we got lucky or we were just too smart or we were right, but the market evolves so quickly that everybody who wants to introduce a product today talks about the ability to build AI on board. When we launched our first family in 2021-22, that was not the norm even. Now, if you look at the AI itself, first of all, you can see what is happening to it, what I call the big AI, correct? The big AI is, my God, it is accelerating like crazy. If you look at the latest generation of the GPT or Llama and etc., I mean, we are now crossing a trillion parameters that these large language models are managing. Along with it, SLMs or the small language models and etc., or even micro language models are evolving very fast at the edge. So as we go from AI, now I think we are entering the area of what I call Gen AI, and soon we're going to enter the area of magnetic AI. So on the AI, the capability was to bring images or other application, type of sensor data in and to do things like keyword spotting, image classification, image detection, or if it is other type of sensors, chemical or motion, to do something with it. As we enter Gen AI, now you have to actually create a content from the data that you collect. And that content can be used to enable applications in health, manufacturing, smart home, and etc. And that's what we wanted to enable. So the second generation, which is the one that we have announced and we are taking pretty much in the market, we wanted to bring the ability to enable Gen AI. So from the use of the NPU in the first gen to the use of the NPU in the second gen, our current NPUs now support what we call transformer operators that enable the ability to write language models that can actually run Gen AI. And that is the importance of what we did.
And I
it's
just
going to
want
evolve.
to clarify for everyone, because I think you said a really important thing there. The Gen AI that you're talking about in these edge devices is that small language model based, right? Which, and the folks who are regular listeners to this podcast will have heard me say this on every episode for the last million times, is I think the most functional AI in terms of industrial or enterprise use. I mean, the large models are interesting, but they're mostly not for sensitive or edge or direct business case, engineering case uses, as far as I can tell or have ever seen. So I think it's really interesting that you guys have sort of focused in on that and are enabling that kind of Gen AI at the edge.
No, that is very correct, because the applications at the edge or the endpoints are very different than the applications that run on the servers or big machineries, correct? Which are massive amount of,
Yeah,
which they include massive amount of parameters that have to be managed through a very large language models. When it comes to the endpoint or the edge, all of a sudden the constraints change very rapidly, because first we're talking about a very, very broad and fragmented base of applications,
right.
which means there is a demand to run language models that can be small, medium small, or extra small, correct? And they all have to be super optimized to run, because there's when you look at the endpoint or the edge, there is a footprint constraint. You can't just put a huge, board in there with a fan to cool it down. It has to be very small. And then think of a wearable device, correct?
Yeah.
If a smartwatch, it has a very small footprint. The device on it has to have a small size, has to have a lot of integration, and needs to run on a battery.
And it needs to be pretty resilient to the environment and shock and all that sort of stuff too. I mean, it's a big challenge.
Exactly. And it needs to do a lot of local processing before it has to start communicating with the cloud to start, transferring data back and forth. And those are the capabilities that we're trying to build. And in our business, at least, hardware is still the constraint. Software is running ahead of the hardware. For example, you can create any small language model, any size. The problem is you can't put it inside a size constraint or memory constraint device which runs at an endpoint. And that is what we're trying to do. We're trying to break that barrier and just keep evolving our product line in such a way to enable that to become more and more a reality.
Mm-hmm. So I know that you guys are mainly concerned with the MCUs, at least with this announcement and stuff, but MCU is never a standalone island. There's a lot of load that it needs to carry in terms of ability to support peripherals and a bunch of other things, especially in the edge. Everybody wants to connect up their sensors and their data collect and then processing and all that stuff. Can you talk a little bit about the capabilities in a real world situation if an engineer is looking to layer one of these new Ensemble devices into their next solution? What are some of the capabilities they can expect?
So definitely, I think you made a comment that I'd like to say something about, because an important comment. If you look at the microcontrollers of yesterday and compare them to the microcontrollers that are needed for tomorrow, there's a very big difference.
Okay.
For several reasons, correct? So if you look at devices that need to run the endpoint, for example, take a very good example. Take the case of smart glasses. Smart glasses are becoming a new trend, mainly because there's a lot of expectation that they create a new way for humans to interface with a machine. So it's really a machine-to-human interface improvement, may replace some of the functions of a cell phone. Cell phone may still remain as a communication device, but nothing that you would constantly use to type in or to punch in or to look at the screen. It may all happen is to be seen how far this will go, but at least there's a trend.
Right.
Now, if you look at those smart glasses, and that's kind of the example use case you wanted me to probably talk about, the idea is, in order to make them popular and I would say practical for the common person who want to use them, first they need to look stylish. Two, they need to weigh less than 40 grams in general. You don't want to wear a heavy pair of glasses with thick frames on your face, correct?
Right.
Now, three, this type of devices or this type of smart glasses have to at least last a few hours, somewhere about 10 to 12 hours on a battery charge, because you cannot be driving and all of a sudden your smart glasses run out of power, correct?
Right.
And yet they have to interact with image sensors, multiple cameras that can look, let's say, to the outside. They can look at the retina, so they know what you're looking at. They need to have microphones. They need to have other type of sensors that may actually monitor movements and the number of steps you take. So a device that you want to use has to be a type of device that doesn't need to constantly communicate to the cloud to make decisions, has to have certain decision capability on what we call local processing, the ability to run AI locally, communicate to the cloud as needed in order to reduce the amount of communication to the cloud, and also to reduce the amount of power consumption. So you need a low latency device, you need a real-time operating system, you need an extremely footprint constrained device, and yet very capable. So that's a very good example of how the microcontrollers of tomorrow have to have the proper compute engine, have to have the NPU capability to run a good amount of SLMs, have to have a lot of integration, because you cannot put multiple different chips inside a frame. And that's kind of where a very good example of an MCU comes in. Now, by the way we decided to create our product, we decided not only to create an MCU version, but also what we call a fusion processor, which also has an MPU core on board. So the user can run a light Linux system or a real-time operating system or a Zephyr if that's what they run, if they choose to run, mainly because there is not one single application. We are going after a broad base of applications that typically microcontrollers or embedded processor go to. Can go all the way down to a smart coffee machine or appliance, or go to a security camera or a smart watch.
Yeah. What about on the connectivity side? Are you guys interfacing at all with sort of layering any cellular or LoRa or any of that stuff in?
So in my opinion, it is, by the way, we have a wireless version of the device as well.
Sure.
But in general, if you look at the different wireless communication protocols like Wi-Fi or WAN or LAN or LTE or BLE, different use cases, it's going to be very difficult to mix and match analog plus RF plus memory plus digital constantly and create a broad family, correct?
Right.
And it's also my opinion, it is the best for the user to have a very optimized diffusion processor, which can run everything that is needed to be run as a real-time operating system or as an MPU, and communicate to a secondary chip, which can be optimized for the communication protocol that the user wants. It could be a Wi-Fi BLE combo in some cases, or it could be an LTE in some cases. And our job, or at least our approach, is we offer a seamless communication channel, either through I2C or I2S and etc., so they can easily talk to each other. But the user has the ability to decide, okay, I'm going to match this with this, rather than having to look for something that is combined, because then they can also optimize power consumption. You do the communication only as needed, but that can be always off until you tell them, okay, now I'm ready to communicate. That can happen better in a multi-chip system versus a single chip system, in my opinion.
Absolutely. And I think I want to bring our conversation up higher. And you touched on something that I think is a big issue, especially when we're talking about Gen AI. And as we get more and more artificial intelligence applications and tools embedded into, everything from smart glasses, smart watches, all the way up the line to, big industrial equipment and cars and everything else, is the power issue. Not just consumption, but efficiency and supply and storage and all that stuff. I think there's an argument that battery is the big technological hurdle that we have to overcome in the next 10 years if we're going to keep progressing sort of technologically, because I think it's not even controversial to say that we're not there yet with battery technology for what we actually need. So I would love to hear your thoughts on sort of good power, like designing for power strategies. What approach does Alif take? What are your thoughts on how designers and engineers should be thinking about power efficiency? Because it always takes some amount of power, but we want to use as little as possible while getting the most return for it, right?
No. That is very true. I think, one of the interesting, or at least the important factors to have in mind when we talk about power is power consumption may mean different things to different users, correct?
Yeah.
When you look at the range of the applications which are in the marketplace, you can go to the smallest footprint type of device, like, take the case of a ring, correct, that you wear in the ringer, correct? That has an extreme limitation on the size and the space available, correct?
Yeah.
So you have to offer nanoamp or microamps type of currents or microjoule type of power consumption.
Yeah.
When you look at the robot as a whole, it's a different thing. So there isn't one answer for the question. But from my point of view, or from our point of view, we are trying to look at power with regard to, okay, what is the total system power consumption, correct? So what we did when we were architecting our products, because we have multiple different capabilities we build, we have a very scalable compute engine on board. We integrated our own power management capability on chip, through which we were able to create multiple subdomains within the chip or the SoC. And each one of those subdomains is controlled through its own LDO and its own power switch and its own firewall. So basically, we enable the capability that the user software could easily manage and manipulate how their code is being executed and how our device will talk to other devices on the board in order to do what we call a power optimization. And that's what we do, and that's the way we look at the power.
Mm-hmm. Interesting. And now I'm going sort of afield because I like to follow the rabbit hole down. What about sort of non-traditional? Most of the time we're talking about charging off of mains or whatever when we're talking about power source, or sometimes it's solar or those kinds of things. If you're really out in the edge and you don't want to do rolls out for batteries and things like that. But what do you think about sort of, I guess you'd call them non-traditional power sources like piezoelectric materials or, kinetic power, for like these small wearables especially? And are they actually viable, or they're never going to really keep a battery to the point where it needs to be?
I think generically speaking, and and I'm not necessarily the expert in that field, but
Sure.
generically speaking, I think power sources like that can be practical if you're looking at devices that in general use a very small amount of current or power.
Yeah.
But if you start thinking about devices that have to actually do a good amount of compute and communicate and etc., I think they become a bit impractical.
Yeah. So like, for instance, you don't think that we're going to hit an MCU that's powering via some sort of kinetic or vibrational power generator, right?
In a very small footprint?
Yeah.
Like a very small health tracker that you wear?
Yeah.
Unlikely. If you have a
yeah.
bigger device, a bigger space, and you can put enough of them to actually supply milliwatts or tens of milliwatts constantly, maybe. But it all depends on that application, the amount of size and the space you have, and how much current you need to consume on what function you're asking to do. So
yeah. I ask because it's a personal fascination, the idea of like a microgrid and how small can we actually make the path from generation to use and back. I'm very interested in the idea of making those cycles optimally small. Does that make sense?
No, it does, and I think it really depends on the use case. Let me give you one use case that I think would be practical for. Let's assume that for managing supply chain in a factory or in a warehouse, correct? Let's say you're selling, I don't know, let's say you're selling clothing, correct?
Sure.
And as a user, you want to be able to walk down the store and see on your cell phone what is the price or information on a particular device, correct? Yeah. Particular clothing, let's say a suit jacket.
Sure.
For that type of application, then maybe it's possible to put an extremely small SoC, extremely small, which all it does, it has a number, a user ID number that the cloud could recognize. You could power it by electromagnetic or electrical field as you pass by it, and the cloud would read the number on that small SoC, and the cloud can talk to your phone and say, okay, for that number, this is the information which is already stored in the cloud.
Right.
This way, because you don't want to put a battery or any type of source of energy in there, you just want to be able to power it up to external fields. That could be a practical application.
Yeah.
But if you want to wear something on your body that constantly monitoring your temperature or your oxygen level or your movement and talk and run an AI and tell you, okay, you got to get up and walk, or you're sitting too much, or it looks like your pulse rate is going too high, I don't think so.
Yeah. The thing that makes me think of that are, obviously medical devices that you bring up, like, say it'd be incredible if we could figure out how to do that for things like pacemakers or other implantable devices, because those have to be taken out every 10 years or so to get new batteries and be refreshed. And it'd be really incredible if we didn't have to do that, because obviously that's an invasive procedure on someone who's already had one. So I'm sort of always interested in these subjects.
But the future is, it's too early to decide what's going to happen.
This is why I refuse to make predictions. This is why I refuse to make predictions, because the old rule is they never remember the ones you get wrong. But I will remember, and I don't want it. Reza, this has been a really great conversation. Thank you so much for chatting with me today. Folks can go to alifsemi.com to find out more about the release and the new E4, E6, and E8 microcontrollers, right?
Exactly. And it was a pleasure talking to you. Okay.
The pleasure's been entirely mine. Folks out there listening, thank you so much for joining us. Stick around. There's always more Embedded Insiders to enjoy. In the meantime, make sure that you subscribe, share this episode with your colleagues, and have a marvelous day. I've been Ken Briota, your editor-in-chief and your host.
Now, here's editor-in-chief Ken Briota.
Hello, embedded engineers, developers, and friends of the show. Welcome to In Case You Missed It, Embedded Insights, the weekly news show all about embedded technologies and solutions from your friends at Embedded Computing Design. It's Friday, October 31st, Halloween 2025, and I'm Ken Briota, editor-in-chief of Embedded Computing Design. It is All Hallows Eve, and these are our top terrific stories this week. First up, Pollen Technology has announced the successful manufacturing and testing of the world's first silicon-proven implementation of its unique NASP technology. NASP stands for Neuromorphic Analog Signal Processing Technology. The NASP platform utilizes trained neural networks in the analog domain to perform AI inference with lower power consumption compared to conventional digital neural processors, says Pollen. So check that out. Our next story comes from GP Singh. He's the CEO and founder of Ambient Scientific, and he's written a column for us about how analog matrix computing is bringing about a breakthrough for high-performance edge AI on battery power. This is a much-needed path of innovation and an engineering challenge that's been going on a long time, so check it out and make sure you give it a read. Finally, we are featuring Advantech, which has released several edge AI solutions, all powered by NVIDIA's new Jetson Thor module. They can deliver a reported up to 2,070 FP4 teraflops of AI performance. These solutions are built on container-based architecture and feature application-specific hardware platforms pre-integrated with Jetpack 7.0, remote management tools, and vertical software suites like Robotic Suite and Gen AI Studio, Advantech says. So that is worth an investigation of its own. Next week, your embedded computing design team will be in Anaheim, California for Embedded World North America. This is the second year of the North American version of the gigantic German trade show, and we hear it's growing like crazy for the second year here. We're excited to see what the show has to offer, and we are doing our part. If you're going to be there in Anaheim, make sure you swing by our booth and see our dev kit zone, where some of the most interesting and exciting dev kits in the industry are going to be on display. Make sure you visit with our kiosk partner music.ai and join in on our scavenger hunt to earn either a t-shirt giveaway
or a Raspberry Pi board, or both. And of course, we will be bringing you tons of editorial coverage, including our special episode of In Case You Missed It from the show floor. So make sure that you are here on YouTube to see it all. That's it for this week. Make sure you look for the In Case You Missed It LinkedIn newsletter, as always, for even more stories that you don't want to miss. That comes out every Monday on LinkedIn, and you can subscribe to it there. I hope you do subscribe there, but I have found, looking at our analytics, that many of you watching us here on YouTube are not subscribed. And I hope that you'll take this moment to subscribe, like this video, and click that notification button so you never miss any of our episodes. Visit us on embeddedcomputing.com for all the news in the embedded computing space, published every day, every week, throughout every year. Follow us on LinkedIn and all across the web. And please reach out if you'd like to become an advertiser or a sponsor of In Case You Missed It or any of our shows. For now, however, that is the end of this show. Make sure you never miss an episode of In Case You Missed It Embedded Insights. Happy Halloween. I hope you have a great weekend. And I'll see you next week from Embedded World North America.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.